Hi guys, I hope you guys are well. This is Converse of Theorem number 1. But before we start, I would like you guys to please like, subscribe, as that is also a motivation for me to keep on posting the videos. And I would like you guys to please comment on the comment section below. And if you have more questions or you think maybe I might have made a mistake on the videos, I would leave my number on the description box below. Please feel free to contact me, WhatsApp, call, or anything that it will be best for you. So let's get into this Converse of Theorem 1. So the statement that we have here says that the line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. They are basically saying that if you draw a line from the midpoint of a chord, you see JL is a chord. If you draw a line from the midpoint of a chord to the center of the circle, that line is perpendicular to the chord. So this is what the statement is basically saying. If you draw a line from the midpoint of a chord to the center of a circle, that line is perpendicular to the chord. And now we are given that O is the center of the circle. We are given that M is the midpoint of the chord JL, and such that JM is equals to LM. So this is a midpoint. It divides or it splits this into two equal, not equal halves, but it split them into two. Can say equal halves because they are two. Now what we are required to prove, we are required to prove that OM is perpendicular to JL. We are required to prove OM is perpendicular to JL. How can we prove if OM is perpendicular to JL? We know we have to prove that the angles, or the easiest way to prove is that the angles in between the perpendicular lines have to be 90 degrees. So this basically means that angle M1 must be equals to angle M2, both equals to 90 degrees. I hope we all can see that. Remember, on the previous video, we mentioned that if lines are perpendicular, they form a 90-degree angle in between the line, or the angles that are formed by the lines is 90 degrees. So let's go ahead and try to prove this. You remember I said for us to prove such problems, or if we are proving that sides are equal, or proving if angles are equal, it's best we use triangles. So now we have to construct here in order for us to have what? To have triangles. So we can join OJ and OL. That will be our construction. We joining OJ and OL to form these two triangles, to form the triangle OMJ and triangle OML. So in these two triangles, let's see which sides are equal and which angles are equal. So if we can find three conditions we can conclude that this triangle is similar to this triangle. So we will have proved that this angle is equals to this angle, because this is what they are basically asking us. If OM is perpendicular to JL, that means this angle is 90 and this angle is 90. So if they are both 90, that means both of them, they are equal. So now let's try and look at our first condition. If we can look clearly, OJ and OL OJ and OL. These are lines drawn from the center to the circumference of the circle, from the center to the circumference of the circle. That means they are both radius. So OJ is equals to OL. Your reason is radii, because they are now what? They are 2. And then second condition, let's look at our second condition. If we can look clearly, OM appears in both triangles. OM appears in what? Both triangles. OM is equals to OM. Reason is that OM is common. And then let's look at our third condition. We are given that JM is equals to LM. This is given. You can see they are equal. JM is equals to LM. It's given. From here, the midpoint of a chord, they are saying the line is drawn from the midpoint. You know what a midpoint is. If this is a midpoint, that means this side is equals to the other side. And then now we can conclude that therefore triangle OMJ is congruent to triangle OML. What's our reason? We've proved a side. The radius, these are sides, and this is a side, and also this one is a side. So we've proved 3 sides. Side, side, side. Therefore, angle. Okay, I want you to listen carefully now. If we're saying that these lines, if we're saying these triangles are equal or they are congruent, that means M1 is also equals to M2. But now these two are on a straight line. They are on a straight line. The two angles are on a straight line. So the only way angles on a straight line can be equal, and when you add them, they give you 180, is when each of them is 90. So that's the only way that when angles are on a straight line and they are equal, and when you add them, they give you 180. So angle M1 is equals to angle M2. But JML is a straight line. Therefore, angle M1 is equals to angle M2, they are equals to 90.